you should know already that if two lines are parallel, then they will have the same gradient. That can be really helpful. But there's also a very interesting property about how the gradients of two perpendicular lines relate to each other. And that's what I want to focus on in this video, and then we'll finish with an example. I've drawn two lines here. They are perpendicular, they are at right angles. But let's take a look at the gradients. There are different ways of thinking about the gradient, but if you notice, this line, for every 1 unit or 1 box that I move to the right, I have to move up 2. That's consistent all the way. So the gradient of this line is 2. This other line, for every unit that I move to the right, I have to move half a unit down. Half a unit down. Half a unit, all the way, half a unit down. The gradient of this line is -0.5. And it's not a coincidence that the gradient of the first line and the gradient of the second line, if we just look at what happens if we multiply them, it's not a coincidence that that makes -1. Because the rule for two perpendicular lines is that the gradient of one multiplies the other always to make -1 as a total. Now that's all well and good, but there's actually an easier way to think about it. If you notice the 2 pairs up with -0.5. Now -0.5 is the negative reciprocal of 2. You should know that a reciprocal is just basically a fraction that's been flipped. So 2/1 here, 2/1 has been flipped to become a half, but it's got a negative on the front. So -0.5 is the negative reciprocal of 2. Put it the other way around, 2 is the negative reciprocal of -0.5, because if we look at the negative reciprocal of this, we lose the negative sign and this becomes 2/1. We're left with 2. So in your mind you can say that 5 pairs up with -1/5. -1/4 pairs up with +4. Even something as awkward as maybe you've got a gradient of, let's make something up, -4/5. That tells you that the gradient of the perpendicular line, first of all, it will be positive, but it's going to be the reciprocal. So a gradient of -4/5 for one line tells you that the gradient of the perpendicular line must be 5/4. And if you check, you can see that they do in fact, again, multiply to make -1. This is a really important rule. And we're going to finish this video by looking at this example. Find the equation of the line which is perpendicular to y equals 3x plus 5 and passes through 2, 7. Now, the way to do this is not to draw a scale drawing and try and do it from that point of view. But it is worthwhile drawing a quick sketch of what's going on, just to get an idea. So y equals 3x plus 5, a fairly steep positive gradient going through +5 on the y-axis. That line might look a bit like that. This line, which is perpendicular to y equals 3x plus 5, is to go through 2, 7. 2, 7 might be somewhere there, perhaps. And the line that goes through this point and is also perpendicular to this line is going to look something like that. So I can see that I've got a negative gradient. I can see I've got a positive y-intercept. All these things will help me judge at the end if my answer is believable. Now, let's see what we can do. Y equals 3x plus 5. M, the gradient, equals 3. So the gradient of the perpendicular line must be -1/3. And this new line, this perpendicular line, must pass through 2, 7. So this is an x value, this is a y value. And we know that this blue line, this line that we're trying to get an answer for, it's a straight line. It must follow that rule, y equals mx plus c. And so I've got things that I can substitute into this. I've got this y value of 7. I've got this gradient negative 1/3. I've got this x value of 2. And so I can substitute those in and then do a little bit of work. I can add 2/3 to each side, so that I've got 7 and 2/3 equals c. And now I can put all this back together, and I can say, well, in that case, y equals m, trace it all the way back, m is negative 1/3, negative 1/3 x plus c plus 7 and 2/3. And so I've got the equation of the perpendicular line which goes through the required point. That could not have been achieved if I didn't understand the relationship between two lines which are perpendicular to each other. And so it's critical that you understand this rule about perpendicular lines.